In this video, we will briefly review how to create a box plot. First question you ask yourself, what type of data? Quantitative, categorical. If quantitative, then you can make a box plot. There are 5 numbers that you need to know. So notice here we have our minimum value. We have the minimum value. We have Q1, the lower quartile, the median, which is the middle value of all the data, Q3, the upper quartile, and we have the maximum value. Once you've identified these 5 values, called the 5-number summary, it's fairly easy to create your box plot. So, first thing you want to do is you want to put the data in ascending order. Notice I already have my data in ascending order. Once you have the data in ascending order, you then ask yourself you then identify the 5-number summary. So once again, we are examining the boys varsity B lacrosse team and their times to complete the agility shuffle. Notice that the time is in seconds and we are dealing with quantitative data, therefore we can create a box plot. We now need to identify the 5-number summary. So first values that are the easiest, the min and the max. Minimum is the smallest value, so we can easily see that the min is 12.7. And the maximum is the largest value, and we have a value of 17.4 seconds. So we've already identified 2 out of the 5 numbers. Let's now look at the median. The median is the middle value. The median is the middle value. We need to divide this data in half. Sometimes the median is an actual data value. Other times it's an average of the 2 middle numbers. In this case, we can see that the median is our 12th data value. The 12th data value. If you were to count, you would see that you have 11 data values above the median and you have 11 data values below the median. So 13.7 represents our median data value. 13.7 seconds to complete the agility shuffle. We need 2 more values, Q1 and Q3. Q1 is the 25th percentile. Q1 represents the middle of our top half. So we want to know what is the middle value for the top half of our data. What's the middle value for these times? Once again, we're looking at 11 data values. Since 13.68 is the median, we do not include 13.68 in our calculation of Q1. So we need the middle value of this top half, and the middle value will turn out to be our 6th data value, which is 13.4. If you count, we have 5 values above and 5 values below. Q3, so we have 13.4 for our middle value. Q3 represents the middle value for this range of values. So Q3 represents the middle value for our slowest members of the boys lacrosse team. We need to have 5 on either side, 5 data values on either side. So 1, 2, 3, 4, 5. The 18th data value represents Q3. And this should have been Q1. So Q3 is our 18th data value, which is 14.1. Now that we have these values, we can easily make our box plot. Our Our whiskers will go out to the min and the max. So we have the lower whisker, our min, at 12.7, and we have our upper whisker, our max, is 17.4. The ends of our box, the box and whisker, the ends of the box are at 13.4 and 14.1 are quartiles. 13.4 is approximately here. When you're making your box, you make them a little bit bigger than the whiskers, and 14.1, which 14.1, which is right around here, and the median is at 13.7. And we complete the box, and we fill in out to our whiskers, and we've created our box and whisker plot for the boys varsity B lacrosse team. So we need a title, boys varsity lacrosse agility test, and we graph the time it took the boys to complete the test in seconds. And notice this box plot tells us the 5-number summary, and but it does not tell us the individual data points, but we can understand the distribution. So always be thinking about what percentage of data falls within each area. So you should be able to tell me what percentage of data falls between the min and Q1, what percentage of data falls between the median and the max, and perhaps what percentage of data falls between Q1 and Q3.